Thanks for the warm introduction. Hey everyone, thanks for sitting in. This is the last talk of the day. They probably didn't want me to speak too much, so they put me in the last. But thanks for sticking around. By a raise of hands, I'd like to do some polls before starting. How many of you are actually building on top of LLMs? Almost all of you, awesome. Please keep your hands up if you're trying to fine-tune language models at all. Awesome. How many of you have already done that? Quite a few of you. Great. So I'm here representing my company, H2O.ai. We think of ourselves as a cloud vendor that builds different vertical AI solutions. We're also building in the space of LLMs. So I think just yesterday, we've open sourced 1.8 billion parameter model. I invite you all to check it out. I invite you all to trash talk it if you don't like it. This is open source Apache 2 license. And for today, I wanted to give you a taste of how you can use H2O LLM Studio to fine-tune models and give you a whole picture overview of how you go from zero to fine-tuning. So I know this is the last talk of the day. I'll try to keep it light. What I'd like to cover is possibly give you how we got to large language models. So a very quick recap of that. I'm sure you've heard that 50 times already today. And then I'll give you a hands-on demo of LLM Studio and why you might want to use it. All of the tools I'm using today are fully open source, and I'll keep it that. And yeah, hopefully we have time for Q&A towards the end. But if you're interested, I can share the links later on as well, or if you look up this stuff, you can find it pretty easily. Cool. A few words about H2O that I've already mentioned. We build different AI engines and different tools for deployment, different applications. We've recently open sourced the GenAI Cloud as well. I can share the links to that as well later on. But if you'd like to check those out, you can go to our website. I'll keep the corporate talk to a minimum, but we're quite proud of a lot of the things we've put out, so I invite everyone to check those out or find me later on if you're interested in all of that good stuff. What I would like to focus on today is the last in this title, which is the H2O GPT project and the fine-tuning suite that comes behind it. We've been hosting a lot of open source models as soon as they launch. So I'm sure a lot of you would have heard of Mixtral. Yes, I'm hearing a few yeses. The model that came from the guys at Mistral AI, the weird people that drop torrent links and just disappear. We've been hosting a lot of those models as soon as they come out for free. This is where you would find most of them. That's the link gpt.h2o.ai. All of this is to say that we are a team of very seasoned modelers, very seasoned builders, very seasoned Kaggle Grandmasters, and we are very active in the open source space. I'm mostly known for LLMs and mountains these days. I started this fun joke that I'll be on a LLM vacation, and that went on for at least 250 days. So I'm mostly known for posting paper summaries with these photos. And my most common question is, are these real photos? All of them are. Yes. People always assume they're not. For some reason, they are always. For the agenda today, I'll give you a quick rundown of the timeline of these models. I'll give you a rundown of 5 stages that I think are involved in building LLMs, and then the tutorial on fine-tuning. So the theory will be only 10 minutes, and I'll try to keep it interactive towards the end. This is the most scientific definition I've found of what is a LLM. I'm sure you've heard many. This is the best stakeholder answering way that I have discovered, which is that is a language model and that is a large language model. But to put a more formal definition behind it, here's another one. Large language models are models that show emergent abilities. So these are the models that are able to showcase behavior that they weren't trained on. Here I just asked ChatGPT to reply with the same thing. It can't do all of this. But the idea is these models are only trained to do next word prediction, right? But somewhere in that training, somewhere along that time, they learn how to figure out what does ordering a pizza mean, what are the hassles of dealing with Bangalore traffic, and they also learn empathy on all of those things which they were never sort of explicitly taught. So all these models, while being trained, were good enough to just do next word prediction, right? And somehow they learned, okay, different few things about the word, how to write code, how to do all of that good stuff. All of this has been the main promise of the Gen AI boom, which is the fact that these models can now properly act as AI engines, properly act as logical engines that can solve different things, that can solve different use cases. And while earlier a lot of efforts were, let's say, involved with creating specialized model, creating specialized pipelines, a lot of that now is being replaced with the pain of just hosting these models and how to bring that cost down. But the main reason or promise is, especially in the demo stage, you see a lot of promise and then you crib about the hallucinations. The main reason for all of that promise comes from these emergent abilities, in my opinion. So this is sort of the ecosystem that we are in as builders, which is that OpenAI is now closed source and Microsoft is the hottest AI company because they're the ones who are partnering up with all of the open source companies, which sort of limits our option but also expands it per se. But I would say most of the companies I know in Bangalore and otherwise are only building on top of open source models for good reason, because just by doing that also you can get really further, you can get really far. So I'll spend a few minutes talking about this tree, just for historical purposes. It's cool to see how this field sort of emerged. So if you look right at the 2018 mark, right, this was when we did not have pre-trained models. So before this, we didn't have pre-trained NLP models. But right at this point, the ULM fit paper came out from FastAI. I was a student of FastAI back in that day. And this was the first paper to show that pre-training in NLP is something that everyone should be doing, and no one was doing it at that time. Right in parallel at that time was when GPT-1 came out. So as soon as ULM Fit showed that, hey, you should be doing this, the Bird paper came out, which taught everyone about attention. And that's when GPT-1 came out. So the seeds for the architecture were already sown. And if you see, the tree has only evolved in the sense that we've scaled up the compute, scaled up the training. And we keep doing that. I'm sure we'll see larger and larger models. I don't see that trend going away, at least in terms of performance. The Instruct GPT paper, if you look at the 2022 dash line, you'll see that Instruct GPT paper came out right then. And Chat GPT was basically already proven as a fact in the Instruct GPT paper. The paper said if you train a very powerful language model on the internet, and if you show it examples of conversations, so if you show it questions and answers, it can become a very powerful chatbot and it can do that very effectively. So no one, at least outside of OpenAI, before that thought, hey, maybe we train a model on the internet and we show it some chat examples and now we have like a very powerful bot. Up until that point, we were only working towards that. A lot of those seeds came from the attention paper. A lot of those seeds came from the fact that we can have pre-trained models. There's a lot of debate along if you should be fine-tuning your models or if you should be doing prompt engineering. I think you should be doing both, but this is like a scientific way of me saying that. People think they're cool either ways. I think you should be doing both, and you have to do both. But again, more formally putting more definitions to the 5 steps of these building blocks of LLM. So I showed the papers earlier, but that was just to connect the dots to this. So a lot of the resources and efforts go into creating this foundation model, which is a very powerful autocorrect of your iPhone that just happens to be trained on the internet. So if you take a language model, train it to do next word prediction on the entire internet on tens of thousands of GPUs, millions of dollars later, you will have a foundation model. If you fine-tune that model onto chat examples, you get supervised, fine-tuned models, you get chat models, you get chatbots. Which is why when you go to any model, you'll see Llama 2 and Llama 2 chat. Llama 2 is the foundation model, Llama 2 chat is this SFT, the chat capable model. A lot of our efforts as companies, as builders, usually go into step 2 because this is where you can also bring more knowledge into these models. After that, people figured out that, hey, we've trained these models on the entire internet. The internet happens to be a very, very not safe place. So how do you make these models nicer, politer, safer, not sarcastic, not cussing on every other word? We, at that time, figured out that RLHF is a technique to make them politer, nicer, act in a certain way. Now we're sort of shifting towards DPO. You can look into that. But that, again, I would say slots into step 3. And step 4 and 5 is where most of the businesses are trying to sell stuff, trying to build products, my company included. That would be connecting these models to external APIs, external resources, and having them act in the world. So I would say these would be the 5 steps, the 5 building blocks of LLMs that have emerged as a tried and tested technique. The paper I showed earlier, H2O Danube, which is like a 1.8 billion model, would be a foundation model. Most of the stuff that we do with Llama would lie in step 2 or step 3. And in my opinion, all of the RAG stuff sort of falls into step 4. I mentioned this and I spent some time on this while rushing through this presentation because I think all of us have to eventually spend time from steps 2 up until 5. Unless you have millions of dollars, you can also try step 1. But I think you have to effectively, at some point, learn all the remaining steps as well. And I would say even foundational training at some point, all businesses have to do that. At this stage, once you're doing that, once you're creating these models, you see a lot of these Pokemons emerge that are 7 billion, that are 70 billion, there's 56 billion, there's 1.8 billion. And this is again a good representation that I found to connect the dots with these models. So I like to think of them like living organisms. All of these show emergent abilities, but the smallest model would be the equivalent of a rat, which probably won't be sitting in the audience thinking, why is this guy saying stuff I already know? That would be a human brain, but a rat probably only cares about eating, keeping its genetic line going, and just getting to the next day. So in that sense, it's a living organism, but it doesn't have the higher intellect. So in my opinion, as you scale up the parameters in these models, they're able to do more and more sophisticated stuff, but that's not to discount that the smaller models themselves aren't very powerful, I would say. So I'll quickly recap some of the earlier steps. I'm sure you are familiar with these, but just to briefly touch on it for the sake of completeness. Pre-training is usually the most expensive part of the training, and the best open source dataset, at least at this point, is the Slim Pajama dataset. Very cool name, I know. That came from the Red Pajama dataset. For some reason, no one knows the reason of that name, but that's what we are with at this point. And usually at this point, bigger models usually means more powerful models. So if you have a bigger pre-trained models, usually these are more powerful. Fine-tuning is the way where you give these models A, chatbot capabilities, and B, also downstream capabilities. So let's say you take a Llama 2, which has some medicinal knowledge, and if you want to create a very specialized medicine chatbot, at the fine-tuning stage, with just 1,000 examples, you can do that really effectively. These also enhance the API following capabilities of these models. So the Gorilla paper that came out in April last year showed that you can actually have ChatGPT plugins. And now it's common knowledge that you can build agents, you can do all of that good stuff. We also learned that distillation from larger models is a good step at this point. So we take larger models and we're trying to annotate data sets to sort of get some power with the smaller models also at this stage. The 3 applications of LLMs largely exist as A, in context learning, where you just prompt them. It could be in training or fine tuning, or it could be in connecting them into a bigger pipeline. Just a few more words on the best examples I found for these. So I'll let you all read this. The prompt, the set of prompts was, I want you to act as an Indian parent. And this was the response I got out of ChatGPT. I've not been able to replicate this with any open source model. But yeah, this is sort of the behavior that comes out of in-context learning, where the models have already learned about the world and are able to extrapolate that to more things. This is not a made-up example. It's a real screenshot, by the way. Yeah, so it heavily relies on the model capabilities, and usually it works better with larger models. And usually it fails on things that the base model doesn't know about. So if the model doesn't have knowledge in fintech, you cannot expect it to give good answers in that just by prompting. That is where sort of RAG comes into play. I've seen a lot of great talks on RAG today. I'm sure you have as well. That is where connecting these models with external knowledge resources is really helpful. And it can also help give personality or styling to responses. So if you really care about creating a support bot that acts in a certain way, that comes through in context learning. This was, to give credit, this was a paper that taught everyone that you can actually connect a model to external APIs. It was a tool former paper from Meta AI. And this is the origin of ChatGPT plugins and all of the agentic stuff, so to speak, that we've seen. All of this boom in external API sort of happened right around in March last year, I believe. So what I'd like to do now is, after briefly touching on all of these ideas, I'd like to show how easy it is, more or less, to fine-tune these models using H2O LLM Studio. So I have it running locally now. And this is a live demo, so I'm hoping at least something would fail. Or maybe it won't. This is the home page I have for LLM Studio. If it's not very visible on the brag, please shout and I'll zoom in a bit more. What this lets you do is do supervised fine tuning very conveniently. So remember the step 2 that I elaborated on, where you have chart examples and you're trying to give the model external knowledge, you're trying to give it more styled responses, you're trying to bring more knowledge into the model. This sort of helps you with that. It focuses on that part. So it helps you do LoRa fine tuning very easily. It helps you apply different quantizations very easily. This is the home screen where I can show off all of the GPUs that are in one of my machines. The first one was a recent gift from NVIDIA to me, so I'm quite grateful to them. But it works very well with multiple GPUs. It lets you do multi-GPU fine tuning very easily. The whole goal here is, it sort of takes away the pain of managing this hell of dependency with the PEFT versions that break every other day and the other bits and bytes pieces that break every day. Here I can get an overview of my finished and stopped experiments, or the experiments that are still queued. And inside of the settings, I can connect this to my Hugging Face account as well. So all of the models that I fine tune, I can push them directly to Hugging Face or an internally managed cloud space as well if you're collaborating with other people. You can set all of those environment variables right in this setting. Once you've done that, you'd like to bring in your dataset to this platform, right, or this app. So you can upload them directly, or you can connect it with all of these data connectors from S3 data table or Kaggle if you'd like. I already have a dataset, so I'll show off that. It's the Open Assistant dataset. When you have imported the dataset, you get this nice overview of what's inside of it. So here I can see the question and answers that are inside of the Open Assistant dataset. I can see some questions, I can see the answers, and I also can see the parent ID. This is because, if you remember, these are parts of conversations, right? So this message would originally be a part of some chain of messages or some chain of responses from where it's coming. So this sort of ties into that. If I want a simple single page overview, I can take a look at the stats as well, and I can see the distribution inside the dataset. I can get a simple dashboard overview of all of the details, all of the good stuff that's inside this dataset. It has about 8,000 instructions, 8,000 outputs as well, so that looks about right. So all of the data validation and all of that process is sort of taken care of at this stage. And finally, I can also tally my summary, so if it's been loaded in correctly or not, I can confirm that here. Once I'm happy with that, I'll click Create Experiment. So as I've been claiming earlier, this is a low-code or no-code GUI that makes it very easy to do all of this. So if you pay attention, all of the stuff I show you that associates with QLoRa, associates with multi-GPU, will not involve you worrying about NF4, INT16, BF16, all of that. All of these things will be handled by sliders and drop-down menus now. It's already identified the dataset and the problem type as causal language modeling. And if you all are interested in other problems as well, you can also do DPO modeling, RLHF, and a bunch of other things from this. So all of those fine-tuning approaches are possible using this platform. For this demo, I'll only do causal language modeling. And from here, I can select the LLM backbone. I can start with a pre-trained model and continue from there. Or if I have an earlier checkpoint, I can load in that as well. I quite like the Zephyr model, so let me see if I can load in that. This is a 7 billion model, so it should be able to train in about an hour on any modern GPU. Once I've loaded in this data set, there are some default checks that you'd like to work with, right? Like you'd want to load in the data frame correctly, you'd want to identify the validation strategy and the columns. LLM Studio automatically does a lot of that by default. But just for sanity, you can also go through that and set the sliders if you want to increase the validation size or if you want to change any of that stuff. Many a times you're creating your own synthetic data which might have different tokens. If you try to change this, it's quite a pain with Hugging Face many a times if you're trying to change the custom tokens because you change it at one place and you forget the other, and it's quite a hassle. Here I can just define the special tokens right here. All of that is taken care of. And I can also set the tokenizer settings. So I can set the max length of the prompt and answers and both of them combined. I can enable padding quantile, which means if all of the batches going into the GPU are uneven, it will automatically pad most of them. This is important because it speeds up training by quite a bit. So for those of you that have fine-tuned models, you would know that this becomes quite a pain when you get to it. After that, the stuff I've been raving on about, if you want to select a particular data type of the backbones, if you want to switch between precisions, I can just do that through this drop-down menu. So I can go from int 8 to int 4 just through this drop-down menu. And I can also enable gradient checkpointing for all of us that are GPU poor. This is key to making things work on smaller GPUs. But for this demo, I'll turn it off. After that, there are a lot of the latest techniques baked into this as well. So I can enable flash attention, not by pip installing those 3 packages, but just by enabling it through this button. And I can also change the learning rate right here. So I'll probably reduce it a bit further. I seem quite happy with this. I think a batch size of 2 is what would fit. So I'll keep scrolling further. And you can see that LoRa fine-tuning is enabled by default. So we'll get the LoRa adapter weights out of this training step once I start it. After this, I can enable augmentation and I can also select the metric that I care about. So if you've used GPT evaluation, that's also possible through this. So you can put in your OpenAI API and you can get an eval for that. Or I can just set it to perplexity as well, real quick if I want to just measure that. Once you're happy with all of this, I can select the number of GPUs or the GPUs where I want to run these experiments. So let me just run it on one. And I can also choose to compile my model. So if you've seen the latest torch.compile, that is also enabled by a simple button here. And if you want to use deep speed, which is from Microsoft, for further speed ups, that can also be done right here. But for now, I'm happy with this. So I'll click run experiment. And this will automatically queue experiment. So you can see that I had some failed experiments earlier, some OM ones. You can queue as many experiments and all of them will keep running in order. Which I'm trying to show that this also, in essence, acts as a bit of a MLOps platform where I can get an overview of all of my experiments in a single page. So once the experiment starts, in real time, you can also monitor all of these metrics, but it's true for completed experiments as well. So you can monitor the learning rate and all of the metrics that you would care about in a single page. And it will also give you some insights into how your model training has progressed. So if I go to validation insights, I can see where the model performed the best and where it was sort of messing up per the metric. And this is something we're proud of, but my GPU is already busy. If it wasn't, I could have shown you that you can also chat to the model once it's trained. A lot of the evals are broken in the sense that they only measure this metric that doesn't really translate to your target domain. I would say the best way to evaluate that is sort of just has a set of prompts where most of the models break. So you can also test all of that right inside of this interface. And if I want, I can also compare multiple experiments and keep an eye out over all of that. So since this model has started training already, I can show this screen where I can prove that you can also monitor a lot of this stuff in real time. So my main hope was to show you all that with this open source tool, it's fairly easy to approach the fine tuning parts. Again, we don't sell this as a service, it's fully open source, it's Apache too. So I'd love if you all would be interested later on in trying this. But that was my main aspiration, to show that this is very easy as a platform to use. With that, I'll wrap up and take any questions if there are any.